we've covered parallelograms. Now we're going to cover rectangles, okay? We are not going to go into every property of a rectangle because of time, but we are going to hit the main points. You should know the majority of the properties of a rectangle, because if I was to say to you right now, draw a rectangle, everybody would draw a rectangle correctly. I have the confidence that everyone knows what a rectangle looks like. When you draw the rectangle, what do you notice about the sides of a rectangle? Like when you go to draw it, especially compared to a parallelogram, which we just, finished talking about. What do you notice about the sides of a rectangle? Opposite sides must be what? What? Congruent. Otherwise it's not a rectangle, right? You all know what a rectangle looks like. If you go and you draw a shape and it looks like this, is that a rectangle? No. I drew it on purpose, two totally different side lengths right there, so to try to drive the point home. But if I say draw a rectangle, you basically put draw the two corners, 90 and 90, and then the rest fall into place, right? So opposite sides are congruent. So I'm going to come here and make marks. This is congruent, this is congruent. Opposite sides are also parallel. So this runs along with what we've already been practicing with parallelograms. So opposite sides are also parallel. Opposite angles are congruent. Consecutive angles are supplementary. Starting to ring a bell? Meaning they add to 180. Now remember, it's only angles that add to 180. Yesterday on the quiz, a few people were adding lengths to 180. Brian, join me please. Yesterday on the quiz, a few people were accidentally adding up like segment lengths to 180. You never throw 180 in with a segment, okay? 180 always has to do with angles. Diagonals, what? Bisect each other, which means you've got that, part, or not part, but something equals something. Now, here's the new properties. So rectangles have the same properties as parallelograms. Notice every single one of those was the exact same that we talked about with parallelograms. But they have two additional properties. All right angles. How many degrees are in a right angle? 90. Every single corner angle is 90 degrees. Whereas in a parallelogram, we didn't know the corner angles. We just knew that the opposite angles were equal and that the same side angles added to 180. Now we actually know that the corner is total 90 degrees. And then diagonals are also congruent. This is a new one. So you got to think back to a parallelogram. When the parallelogram was tilted, you had a long diagonal and a short diagonal. Well, now it's no longer tilted, it's upright, which means that the diagonals are the same length this time. So if you know one diagonal, you know the other. And because diagonals bisect each other, if you know that, say, this is 5, then you know the other's 5, and then the entire other diagonal would be 5 and 5. All right, let's make some notes on here. They've already put the little right angle angle symbol to let you know that the corners are 90. We can't really draw that the diagonals are equal to each other because of since they cross, it would look weird. But we can draw that they are bisected in half. So all 4 pieces are equal. Now, you still have alternate interior angles in here if diagonals are drawn. So I don't know if you have room, but you might want to make a note. If diagonals drawn, look for alt-int angles. They will come up. So keep that in mind. They only come up if the diagonals are drawn and we're talking about angles. Okay, let's do these 2 practice problems. If JKLM is a rectangle, find each missing measure. There's a lot of things going on here, right? So this is another one of those where it helps to look at the picture, label what you can, look at the questions, and ask yourself, what's it actually asking for? So if it's 2 letters, it's a what? It's a length. These are segments. Whether it's the edge of the rectangle or whether it's the diagonal. And then what are these? These are angles. So remember to look at the correct property and match the correct buzzword before you run with. All right. Okay. Before you run with the property. So like 180 should not play a role in any of these that say segments, because we just said 180 is always with angles, not segments. All right, let's look at the picture and see if we can just fill in info without even looking at the question. So watch. The first thing I work on is the edges of the rectangle. I know this is a rectangle. So if this is 35, what do I know? What KL would be 35? All right, if this is 19, then what do I know? KJ is 19. If this is 20 right here, LN is 20, but it's a rectangle, so we actually know the others are 20. Because remember we said that the diagonals are equal and they bisect. So you got 4 equal parts in there. The angles are the hardest part, so I hope to be able to help you with that. This little piece here, it's saying is 61 degrees. Well, what do we know the corner is, y'all? It's a rectangle. We know the corner is 90. So do I have enough to find the other angle in that corner? Yes, I do. How would I find it? 90 minus 61 is what? Is it 29? Here's the really cool part about a rectangle. While the angles are the most challenging part for some people, if you know a single angle in the rectangle, you can find all of them. Here's how. Watch this. It's crazy. If this is 61 right here, go across the diagonal, opposite side of the diagonal, and then go to the other end. What would this be? 61. Because that's the alternate interior. Which means that this corner is 90, so what's this angle? 29. Now we can keep going. Watch this. I need you to focus your attention right here. What shape is that? It's a triangle. What type of triangle? Isosceles. It's been a few weeks. Do you remember what we said about triangles and congruent sides? Huh? Just try. Help me out. Let me just come at me with what's in your head. Do you remember what we've said about triangles and the number of congruent sides? Bottom. Angles. Remember we talked about if you have a triangle, however many congruent sides is the same number of congruent angles. Remember that? And remember we practiced turning it like a rooftop. So you do have to turn your head sideways for this to look like a rooftop, right? Like this would be the top right here. If this is congruent to this, and I turn it like a rooftop, then this 61 is also 61 here. Do you see that? And that's the same for the rest of the triangles. Notice that this is also isosceles. Right? So if that's 29, what's this? The bottom one. 29. Then come over here. What about this? 61. What about this? And you might be thinking, well, that's not all the angles in there. What about the ones in the middle? Look right here, 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 and here. Well, what is the total number of degrees of the angles of a triangle every time, right? Okay, so if this is 61, 61, and I'm only missing this angle, I just do what? Yeah. So 180 minus 61 minus 61. Tell me what you get.
58.
58?
Yeah.
I don't want to write over the end. I'm going to draw an arrow. 58. Now, if that's 58, then what's this?
58.
Because of vertical angles. See how it's like a domino problem? I hadn't even looked at any of the questions. I'm just filling in based on knowing one angle. Do I have enough to find that angle right here? Two ways to find it. You got the linear pair. You can do 180 minus the 58, or you can focus your attention on this what? Triangle and do 180 minus 29 and 29. I'm going to do 180 minus 58. So what would that be? 22? Is it 122? So then what's this? Now I've just filled in that whole rectangle, and when I'm going to go answer the questions, it should be a piece of cake now. So look, KL, we already have it labeled. It's 35. NL.
20.
Yep. KM.
40.
K to M. Make sure you're reading the correct
Did I
numbers.
see it wrong?
No, you didn't.
Okay.
You got it right. It's the diagonal, which means I'm focusing on the numbers that describe length, not angles. So you don't need to be paying attention to anything with a degree symbol. But we have marks on it. This mark and this mark was to let me know that those were each 20. So then the whole thing would be 40, which is why he said that. All right, angle KLM. K to L to M. Well, we just traced the edge and the edge, which means it's a corner angle. What are the corners of rectangles measured? 90. LMK. L, M to K means this angle right here. 61. Then you got L, J, M. Talking about that corner angle. Or not corner, but piece of the corner. All right, let's look at the next one. You'll notice this question now just has a single piece of information on it. So you might actually find these better. Let's look at what we have in front of us. It says it's a rectangle. Okay. What are the corners of the rectangle measure? 90. Does this expression point to the whole corner?
No.
No, it's only pointing to this piece right here, right? Okay, then look at the other piece of information. What's it pointing to? Okay, are they equal? Or do they add to something?
Add to equal. Right.
What? Why? They're alternate interior. So look, this is the angle that we know down here. Go over the diagonal, come to the other end, and is this the angle they also give us? Then they're equal. So that's your equation. It's going to be that they equal each other. Then you're going to solve this for x. Now, did it say find x? No, it said to find the measure of a certain angle. So that means you've got to do what with x? You got to go back and plug it into something. What'd you get for x? Are y'all solving this? Logan, are you working? Are you working? So we got 6x now it says to find the measure of angle QPT. Q to P to T. That is this angle right here. QPT. So is that even the angle that I have an expression for? The expression 16x minus 17, is that the green angle I'm trying to find? No, it's not. So there's a little bit more work here. But what is the corner, though? The corner's 90. So if I plug x in here, I would know this angle, and how would I get the green one?
90 minus.
I'd subtract it off 90. So let's plug 3 in. 16 times 3 minus 17 is what? 31? So this is 31 degrees. So then to get the angle that I actually need, it would be what, y'all? 90 minus 31. What do you get? 59? All right, I want to practice rectangles. You have the practice sheet in front of you. I only want to do odd. I don't want to do all 13. Yeah. Because this is not all we're doing today. So we're going to do 6 problems, and then we're going to look at either squares or rhombus. Probably, maybe squares, because everybody already knows about squares. I don't know. But basically, right now, I want you to do the odd problems. You can work next to a partner as a checker, like a checkpoint person if you want. And then we will go over the answers and then we'll move on. So looking at number 1, you'll notice it's only asking us for segment lengths. It never asks for anything to do with angles. So if we first, remember that we're dealing with a rectangle. If I know that's 24, I know this is 24. If this is 10, this is 10. And I'm going to draw the right angle just so I remember I know what I'm dealing with. I'm dealing with a rectangle. And then you'll notice we don't know anything about the diagonals at all. But we do know the properties of the diagonals, and that is that they are equal to each other and that they've been cut in half. So you have 4 equal parts to them, right? Can you tell me what type of shape is embedded within a rectangle when the diagonals are drawn? What shape do you see in there? Triangles, multiple triangles, right? Can you focus your attention on just this triangle, for instance? Look at that one. What type of triangle is that one? What? It's a right triangle, because what's the corner again? A right angle. I'm going to draw that purple triangle right here without all the other stuff around it. And then this is 10, and this is 24, and then I don't know this side, right? Do you remember a formula starts with P? What? Pythagorean theorem. It's going to come up right here. It's only going to come up with the diagonals, okay? And it's because you have a right triangle. A squared plus B squared equals C squared. There was a rule on C. C can only be the hypotenuse of the triangle. The hypotenuse is always the side opposite of the right angle. So in this case, I don't know C. So I would plug 10 and 24 into A and B. It doesn't matter which one you plug them into because they're both getting squared and then they're getting added together. So the order does not matter there. But I don't know C, so I'm going to leave it as that. So I need to go to my calculator and type 10 squared plus 24 squared and see what I get. Somebody? It's 100 plus, I don't know what 24 squared is off the top of my head. Are you on your calculator? Or but what about 24 squared? Yeah. Do 24 times 24. 276? 576? So this is 676 after you add that 100, right? Now, how do I undo a squared? What's the opposite? Square root. So you would square root 676 and tell me what you get. You have to type 676 first and then hit the square root symbol, which is why you should be on my calculator instead of your phone. No, 14 is 116, 196.
We got 28. I'm just giving a big guess.
It's probably going to be a decimal.
That's a pretty good guess.
26. So C is 26. So this right here is 26. So if this entire diagonal is 26, then what are its 2 equal parts? 13.